Hello everyone, I am Hanita. Thank you so much for your support and I hope you have liked and shared my previous videos. I also hope your journey in learning data science has been enjoyable with the videos I've created. Well, in today's video, we will be building a powerful image classification system to distinguish between dogs and cats using deep learning and transfer learning. This hands-on project will walk you through the entire process, and by the end of this video, you'll be able to classify images of either dog or a cat with confidence. So let's get started. So what is transfer learning? Transfer learning is a powerful deep learning technique where we can take advantage of a pre-trained model. Okay, what it means by taking advantage, I will explain you further. Okay, so let's go on. Essentially, this model has already been trained. So this model has already been trained. Look, take note of the red color text that I've make it into red. Okay, on a large data set for a specific task. Okay, and we can reuse it for a similar task, especially when we have a smaller data set. Okay, so let me explain again. Okay, so transfer learning is like having a head start in a race. Imagine someone already trained really hard for a task, and now you get to use all that knowledge they have built. But it must be for a similar, means cannot be a different task, but it must be a similar task. Okay, so in the world of deep learning, this means using a pre-trained model which has already learned from a massive data set. You can reuse this model. Okay, you can reuse this model for your own task, even if you don't have so much data to work with. Okay, so actually, it's a smart way or shortcut way that saves your time and also boosts your performance. So that is what transfer learning is about. It's really to your advantage. That's what it means by advantage. Okay. So before we begin, let's look at the workflow. Okay, definitely we need a data set, and in this case, because we are going to make the model to understand how a cat looks like, how a dog looks like, so we are going to input this data set with images of dogs and images of cats, plenty of it, okay, for the model to learn, all right, how these cats look like, how dogs look like, okay. Once we have done that, we image pre-processing. Okay, in this case, I'm going to resize all the images because the data set of the images might not have the same size. The dog's cat and the dog's images and the cat's images is a lot, and everything might be okay. Majority of it will be of different sizes. So to prevent biasness, we make everything to be in the same size. So that's what we're going to be pre-processing it later. Okay, and once we have done that, we train test split. Okay, the data set is actually split into training and testing sets to evaluate the model performance. Okay, then we pre-train MobileNet model. In this project today, we are going to use MobileNet model. Okay, actually there's a lot of model that you can use like VGG, ResNet, Inception, MobileNet, and YOLO. Okay, but in this case, I'm going to use MobileNet. Okay, to train the data. Whether this image is a dog or a cat. Okay, so we're going to input an image. I'm going to get any image from the Google and find an image. Let's say I found an image of a cat. I'm going to input it, and then it's going to train, and then it's going to give me the answer. Ah, this is actually a cat. So this is how it's going to predict. Okay. Okay, so without further ado, let's begin our project. Okay, I've renamed the Google Collect file to become dog versus cat. You can rename it as cat versus dog or cat or dog. It's up to you. Okay, so I rename it as follows. So now I'm going to do the code. Well, I'm going to get this data set from Kaggle because I don't have any data set of dogs versus cat. I don't have all the images. Okay, so just go to Google and search for dog versus cat. Do you see? Giggle. Okay, so I just click here and they give me the first one. So I just click this. Okay, click the first one. Okay, so I'm going to use this data set lah, basically. Just go to data set, data, Okay, so I'm going to use this data. You can actually download if you want, and then once you download here, you can upload over there. But I'm going, because in this tutorial, right, before time I've never teach you how to actually import Kaggle inside this Google Colab. So today, okay, one of the reason also I take this data from Kaggle so that I can also teach you how to actually upload your JSON file inside this Kaggle and use all the data sets in Kaggle, because Kaggle is a good platform. You can even submit your work, and there's competition that sometimes can even earn lots of money in it. Okay, so it's a good way that if you learn this. Okay, so if you do not know how to import Kaggle or these kind of things, actually Google is always my my friend. Is always a good way of asking. Okay, let's say it says how to import um Kaggle dataset in Colab, for example. Just enter. Okay, so yep, easiest way to download Kaggle data. So you just click this. Actually, I've done this before. That's why it's you know purple in color. Is it purple? I don't know what color is it. Okay, so you see it teaches you everything. Yeah. Yeah, the IC mode, all this. Okay, so we are going to follow exactly the same, okay? So, pip install QKGO. Okay, but I'm not going to upload file, so I'm going to skip this part here. Okay, so let me just copy this lah, okay? So maybe I just type, okay, pip install Kaggle. But I always like it to have comment before I even start anything. So at least you know what I'm doing, okay? So here I just write a comment installing the Kaggle library. Okay, this is what I'm doing when I do the pip. Okay, so once I run that, and then now I'm going to configure the path of Kaggle.json file. Okay, how to do that, right? Oops, I'm writing file. My JSON is something wrong. Okay, JSON. Okay, so how you're going to do that? Of course, you need to have account in Kaggle itself. Okay, once you have account in Kaggle itself, you have to verify it. Okay, with your images, your own face, all right, etc., etc. They're going to ask you to take photos, this and that. So just follow along. All right. So once you have done that, you can sign in, and then you can go to your profile. Then you go to settings. Okay, you go all the way down. There is something called API. Here is something that you can click create new token. Okay, for me I already have it, so I no need to do that lah. Okay, so what I did, I just create new token. Okay, so once you create a new token, you just click continue, and then it is going to be downloaded inside here. Okay, I'm not going to do that because I already done that. Okay, so please do that. Yeah, create new token and download it, download the file. Okay, I already download the file. As you can see, this is my Kaggle JSON file. Okay, so I configure the path of Kaggle JSON file. So how I do that, just I think over here, right? Yep. You just go to make directory over here, just follow along, okay? Just the Kaggle JSON file you have downloaded, right? So just copy this one. Actually, yeah, never mind. Okay, Control C. So oops, where is it? Yep, here. Let me just close this. I don't need this. Okay, so I just Control V. Okay, so I remove the space. Actually, mm, actually, right, I don't need this one, the space. Okay, so I just remove the space, just run. Cannot create Kaggle file exists. Okay, because I already put the file inside, like that's the reason it's also thick. Okay, but for you, you just copy and then you run. Okay, but before that, remember, yeah, you need to uh upload. Remember, go to this and upload your Kaggle JSON here. Okay, alright, you need to upload the Kaggle JSON over here. Okay, so once you upload the Kaggle JSON, this one will also show something lah. Okay, but for my case, already file exists already, so that's why it just stick. Okay, then continue on to the ch mode JSON. Okay, so just Control C. again, just okay, just run again. I don't need indentation, just run again. Okay, so again my file has already existed, so I don't I just ignore this. For your case, it will not show this lah. Okay, now what I'm going to do is that I'm going to go to code again, or maybe go to text. Yeah, text before this. I'm going to import. So importing the dog versus cat from Kaggle. Okay, this is just configuring, remember, and this is going to be importing. So how I'm going to go do the import? I always have problem with my capitalization. Wait, dog dog. Okay, so what I'm going to do is that, okay, command it Kaggle API. Okay, so remember you have this data set, right? The Kaggle that we have opened up, dog versus cat, and you go to data, go all the way down. There is something that shows the download data over here. So you just copy this part here. Okay, copy this part here, and then go back to your Google Colab, and then you just go to Control V to paste it. And remember, because you're not using Jupyter Notebook, you're using Google Colab, so you need this exclamation mark. Then you just run it. Okay, so this one means it's going to be downloading all the files that is inside this data set. Okay, which is there is 3 files, right? And all the samples as it has is not sample, the test, the train, the zip, all this. Okay, I like to move this here first. Okay, so once you have done this, for my case, right? For my case already down, it's already here. So because I've done this before. Okay, so for your case, see the dogs versus cat zip is all here. Okay, for your case, it will say downloading. So once you finish, it will say 100% downloaded. Okay, just to check it, you can just go to exclamation ls, which is to list. Okay, shift enter. Okay, so you see it's already have all the sample data. Is all the sample data is here. Okay, the everything is here lah. Okay, but the problem is, as you can see, this is all zip file, right? Test one zip, train.zip, everything is zip. So I can see dog versus .zip, all this. So I need to unzip this. So how to unzip this? Basically, okay. Okay, let me see. How to unzip this? You just, okay, let me just comment first. So basically extracting the compressed data set, because this data set over here is all being zipped, is compressed. So you need to extract it, right? So you need to from, okay, that's why I already import, right, the zip just now. Remember I import um the zip file, right? Where is it? Okay, so I need to from zip file import. I need to do the from zip file. Sorry, from zip file I haven't imported. So from zip file import zip file. Okay, okay. Yeah, for me is I just that, but you can type it, or you can go to the easiest way here. That is actually I know that I took it from here that time. Yeah, there's a way also. You can actually just type in here like how to unzip, create a directory, how to unzip the data, right? Then you can search for it, they will give you the answer for it. Let's say unzip, how to unzip. Okay, they will give you the answer for it, because a lot of people has already done it. Okay, so they give you the answers, a lot of it last, then you can just copy. But since I'm doing this video, right, so just follow along with me lah. Okay, so from zip file you import the zip file, then the data set, I'm going to name it a variable called data set. And since I put this under content, okay, my JSON file I upload it under content, so I put content backslash train.zip. Okay, so But where is the train underscore zip? I don't see that. I only see dogs versus cat. So I don't want, I still haven't unzip this file dogs versus cat. Yeah, so maybe I can just, mm, if it's difficult for you, right, you just right click and copy path. Okay, just click on these three things. Okay, and copy path. Then you just put it here, data set. This data set is anything, you can name it as whatever, let's say dog versus cat, etc. Okay, so for me, I just name it as data set. And then this is the path of my data set is installed, what do you call it, is I already upload it here. Okay, then with zip file dataset r as zip. R means to like, you know, sort of extract it lah. Then zip extract all, print, the dataset is extracted. Okay, if you don't want to print also can, but this is just to ensure that it has been extracted. So there is an error. Oops, I forgot to close this. I mean, I removed it accidentally. Okay, so let's run it again. This should be fine. I hope so. It takes a few seconds. Yeah, okay, so this dataset has been extracted. Now, when it's extracted, can you see now the test one and the train is there? Okay, just now it's only docs versus cat zip. Right now I already extract, so test one and zip one is already here. Okay, but test one and zip one, I mean test one and train is also zip. So you also have to unzip this. Okay, so the same method, just the same method. So extracting the compressed data set again. Yeah, maybe I identify this. Isn't extracting the dogs versus cat compressed data set. Okay, in this case, I'm going to just Control C, Control V. It's the same step, yeah. In this case, I'm going to just extract the test one data set. Okay, so extracting the test one compressed data set. So here, the test one zip, I just right click, copy path. Okay, then I'm going to paste it over here, Control V. Okay, so over here, they are going to unzip for me this test zip one. Okay, the data set is also extracted. Can you see that? A lot lah. Test one is over here. If you open test one, right, there's a lot. This test one is already inside this folder. Is all the test one. Okay, and also going to do the same thing for the train one. Okay, the train zip. So again, I'm just going to code again, copy. Is that not like Google? I mean, not Jupyter can just copy this whole, you know, this whole thing. But never mind, just Control C. Okay, Control V. Okay, so this time I'm going to unzip or extract the chain data set. Okay, the zip. So again, I'm going to, oops, did I record it? Yeah, okay, I record it. Okay, copy path. So over here, Control V. Okay, so yep, it's going to be, see the train zip. Now it will have something called train zip. Yep, train, you see the train folder is pink. Let's see what's inside the train zip. It also have a lot of things, yeah. So you already unzip test one, you see already unzip train. You also already unzip the dog versus cat zip, right? From the first, because dog versus cat zip contains test one zip and train zip. So once you unzip dog versus cat, they open up this test one zip and train zip. So once you open it, I also unzip this test one and train. Okay, this is what it has to be done. So this is how you unzip inside the Google Colab. Either way, so I want to check actually how much images all these the train data set have, because I'm going to use first to train before we test, right? So let's check first how much images is there, because all these files is actually images, right? So let's see. first I'm going to import the OS, the operating system, and then I'm going to count, okay, counting the number, oops, the number of files in train folder. Okay, so not really files lah, but images. Okay, okay, so let's see. So you just have to type paths, comma, directories, dirs, and okay, great, start for me, files. Okay, path, directories, files, next operating what content train, because it's inside the, this is inside the folder called content. Okay, it all depends on where it is. Okay, because my train is inside this content folder. Then file count, and you know this is the len to count how many files there is. Then you print the number of files in the train folder. Okay, I don't need the string also actually. Make it difficult also, so long. I like it more short and simple is better, you know. I don't like so long then confusing also. Uh, Actually not total number of files also. I'm just counting number of images. Because you know inside these, right, you can just, if you go to chain, you know how many files is 1, 2, 3, you know. But I want to know how many images inside this chain, right? So number of images. Okay, and here is just file count, that's it. File count, and I don't need so much bracket. Yep. Is there any more error? Okay, yep, because I should number of error. Okay, let me just try run this. Invalid. Okay, maybe I got to be persistent now, consistent, right? I use this kind of open bracket, close bracket, shouldn't use another type. It's confusing. Okay, so wait up. Let me check. Print number of images. I forgot a comma. So file count. Okay, so let's see. Yep. So it tells me the number of images in this train right file. It has 2500. So imagine there's 2500 images, both images of cats and dogs inside this file. That's why it's being zipped, because images is very large in size, right? So yep, that's the thing. Okay, so to further on understanding this data set, right, let's try to print. Okay, so let me just give a text. So printing the name of images, so we know like there's a cat and a dog images, or just, or even other things is inside this data set, because I do not know, I just get from Kaggle, right? So okay, so file name basically is equals to os dot list directory dir. Okay, and again you're going to get this content, train this one. Okay, because you want to print whatever is inside this content, inside in this train data set lah, which is okay inside this content, inside this train. Where is the train here? This one you really unzip and becomes train, right? So whatever is inside here, we're going to list it inside this. So we're going to Control V, alright, and then you print the file name. Print the file name, yeah. This one is just a variable, okay? You can name it anything, fn also can, but I just give it as a file names, okay? So when I print, right? Oh, what is the mistake? OS, not comma, but sorry about that, yeah? OS dot this directory, yep, this should be fine. So it shows me all the files that is inside this chain dataset. Okay, so you have cat0, cat1, you see, all the way to this one is just randomly that they print out, but over here it also open up for you and you can see You see, wow, there's so much images, right? 2,500 images, right? So if you browse down, so cat, 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 cat. How about dog? Let me see if I browse all the way down. No, I didn't seem to see dog, yeah. So, but actually it has lah. Okay, it has dog because over here when it take randomly, right? You can see there's cat 7984, dog 3075, etc., etc. So yeah, if you want to browse all the way down, maybe you browse too fast, you can't really see. Over here, at least randomly you can see, right? If you were to move it all along the way, it's very so much. It's 2,500 of images inside this train dataset. Oops. Okay. So now we're going to import the dependency, okay, all the packages like import numpy, etc., etc. Okay, to start doing our work after knowing and or whatever is inside this data set after extracting the data set. Okay, so let's move on to importing all the dependency and start doing our project. Okay, so let's do the code. Maybe I do the text first over here. Importing, oops, mm, importing the dependencies. Get any code. Alright, so remember we have to always import pandas, import numpys. These are very, very basic, okay? That every data scientist and data analyst has to do, okay? Import numpy as np, import pandas as pd. Yep, it's a great thing that they even that way for us lah. Okay, but in this case, right, we don't need to import pandas anymore because we already import all these images because this file is not data set like in categorical of numbers or binaries, etc., but this is images. It's already import the data set already, so forget about the pandas. Okay, but here we have to do from pi. Okay, from pi, okay, it gives this to me as a pil here. Import image. Okay, this is something that is something new that you need to know. Okay, basically, as I said, you don't need pandas, but because this is an image, right? So you need to use pil instead, import image. Okay, then of course matplotlib. By all this is normal lah. Okay, you know about this, right? To um to view and showcase the graphical, okay, things. All right, and then you also import. This is again for image. Import matplotlib because remember in this case, right? When am I wrong spelling everything? Matplotlib. Remember in this case, right? All our data set and what we want to visualize is also the image. Okay, so we don't need graphicals or graphs, etc., etc. Right? So we're going to use the matplotlib dot image. Okay, as mpimg. So mp image. So we're going to use it as image. This all the plotting is not plotting the graphical statistics of, like linear graphs or bar graphs or scatter plot, but we are going to use the matplotlib as to uh, you know uh, predict and show us the image, okay, from the image. Okay, so again, we need to, of course, import sklearn, which is very important. Import sklearn, and already explained to you the sklearn model in previous video also, right? So, import sklearn model selection, import train test split, okay? Because we definitely need to, did I? Okay, let me just type it properly. Okay, because in this case, right, we're going to split between the dogs images and the cat images, so we need to split also, right? And then, and this is especially for Google Colab because we are using Google Colab, we are not using Jupyter, so we have to include this, okay? From google.colab.patches import CV2 dot im show. This is important, okay, because in Google Colab you may not be able to show your results images, so that's the reason for Google Colab we need to include this part here. All right, so you're going to import all this library. Let's run it. There's some error over here. Import sklearn model underscore. I forget always the underscore selection. Sorry about that. Yeah. Import import train also underscore test also test split also. I forgot the underscore. All right. So let's try it again. Also, there's mistake. Train test import sklearn dot model selection model underscore selection import import, right? Train underscore test underscore split. Why is it wrong? Yeah. Oh, sorry, this is not dot, but it's also underscore. Okay, elements. I'm sure. Again, let me just fix error so do not can be bothered to see what is it. What's the difference? Yeah, the right one is this one import. Oh, no, import is from sklearn, so you don't need to import. Yeah, it's from. Okay, sorry about that. Okay, so from sklearn, you're going to use the package from, right? It's ready from sklearn. Okay, so that's it. Once you have done this, let's go to code and okay, let's say you want to see, right, what's actually inside this all these images that call cat blah 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 dot blah 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 dot jpg etc. Right? So let's display at least one image for us to ensure it's really image of dog and cat. Okay, and it's pretty clear also the image. So let's see, display dog image. So image is equals to this is just a variable that I'm going to call image. Okay, and remember we have already import this, right? uh Why did I get this all from Xboxes, whatever? Actually, I don't need all this. Yeah, I don't know why suddenly it auto type for me. Just this will do. Okay, great. Okay, so image img dot imread. Okay, this is a bit different from pandas. Pandas is pandas.pd dots. So as you know that, right? But for image is this is the way of how you want to read the image and showcase it. Okay, I just tap because and this is the file in the train doc. Okay, and then your image plot dot plt image show just to show the image plot here that I from image from pil image plot right here. I'm using this, right? So I am show also using the Google Colab. If you're using Jupyter, you might not need this lah. PLT show. You just click PLT show and it will show. But because you're using Google Colab, so you need this line, okay? Extra. So let's see. Yeah. So can you see? You can see the image of this dog one. Okay. If I don't want dot one, maybe I want dog 3075. Let's see. Just copy from here. Okay. Never mind. Just from here, I just 3075, right? 3075. Let's see what's the image of this dog, yeah? Oh, this is the dog. This is how it looks like. It's not so clear, lah. Yeah? I think dog one is better. Maybe try to see 5500. Let's see. This one, yeah? 5500. 5500. Let's see. Oh, this is how it looks like. Okay. Great. So it's an image of dog, definitely. Okay, let's try to display the image of cat. Alright. So now I'm going to say display the image of cat. This I did nothing yet. Now I just want to see and display whatever is inside the file. Okay, just like you when you import using dataset which is under just numerical values, right? You use head, HED, remember, and dot tail also to see the data set. What is the first 5 columns? What is the last 5 columns? Last 5 columns, right? For tail, right? But this one is different for images file. This is how you do. Okay. So for cat, it's the same thing. You just got image equals to, yep, I am read. Okay, mpim m mp image dot im read. So instead of dog, I put cat. So maybe cat 5500 if there is such thing. Oh, okay, great. So dog 550, cat is looking like that. Cat 550 so cute is looking like this. Okay, let's say I want it to be cat, another cat. Let's say 7146. Okay, let's say cat 7146, how it looks like the cat, 7146. Oh, the cat looks like this. Okay, good. Okay, great. So I know that in this data set called train, there is images that looks like that, and it has every images also has a name. There is name like cat.7984.jpg, dog.3075.jpg, and so on. Okay, maybe I want to count the number of cat and dog. Okay, how many? I know that both cats and dogs has 2,500, but basically how many is cat, how many is dog, I do not know, right? But so I'm going to do the count. But before I do the count, maybe I shorten this first. I don't need this 7984, all these 3075, all this number .jpg, all I don't want. I just want these three letters, okay? CAT, 1, 2, 3. DOG is 1, 2, 3. It's good that both has three letters, so make it simpler also. Okay, so what I'm going to do, I'm going to just go to file names. I'm going to create a variable file names, just like the same. Variable here is file name, so I just make it similar lah. Okay, so you know that this is the file names of this whatever is inside this train data set. Okay, the list directory. So let me just tab it. So again, OS list directory, which is whatever is inside this train. You are going to list it. But what are you going to list? I want it to list at least, okay, for I don't want to list everything. If I'm going to list everything, it's going to list for me all the 2,500, like this one, yeah? It is going to list for me cat, dog, cat, it's going to be a lot, yeah? I don't want to just, maybe just 5 is enough, okay? So what I'm going to do is just for in range, I'm going to use a for loop, okay? In range of 5, just 5 is enough. I don't need so much like that, right? So what I'm going to do, name equals to file underscore names, alright, and give it an I. So is this an I or a one? I typed wrongly. I, okay. So next is I'm going to print. What I'm going to print is of course print the name, and which is from 0 all the way to 3 because only CAT 3 letters, DOG also 3 letters, right? So let me see, and it's only going to print for me 5 times, okay? Not the long all the list like before. Okay, so what you're gonna do? Yep, see, cat dog dog. See, first see this is cat dog cat dog, and then if I want to, if I print not only 5, it's going to print for me cat dog cat dog cat. You know, it's going to be endless like this, okay? So that's why I just put it into 5, in range of 5, and 0 to 3 means I just want the letter. I don't want the dot blah 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 number dot jpg dot blah 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 number dot jpg. I don't want that, so that's why I just give it a 3. Okay, yeah, so you understand this, huh? Okay, now I want to count how many number of images is consisting of dog images and how many images are only for cat. Okay, so what I'm going to do is that, okay, let me just maybe comment here numbers of numbers oops, why is that? I keep typing dollar sign. Money money mine, is it? Sorry about that. Number of cat and dogs images. Okay, we're going to check how many cats images and dog images are there. Okay, so what I'm going to do is that maybe I'm going to put number of cats. Okay, maybe I just, because I'm going to use count, so I'm just going to put dog count equals to, starting from 0. What is dog count? Oh my god. Dog count is equal to 0 and cat underscore count is equal to 0. Hey, catch. Cat underscore count equals to 0. Okay, when I type everything is funny like that. Okay, so now it started with 0, then I want it to start counting. Okay, so what I'm going to do is that for image file in this file names, okay, because the variables, remember I've named it as file names. Alright, what I'm going to do is you're going to count the dog. And it just give the from 0 to 3. Okay, I don't want like cat blah blah blah. You know, you're just going to count how many cat and dog inside here, right? So you're just going to name. That's why I have already put here as name, right? Name equals to image file, which is from 0 to 3. Okay, we reuse this again, yeah. Sorry about that. Just underscore image underscore file in file names. Okay, name is equal to image underscore file again, 0 to 3. Okay, yep. So then you, if name is equals to dog, right, you're going to count it. Okay, so if name equals to dog, then you count the dog lah. Yeah, yep. Dog count plus equals to 1. So first you start with 0, right? So if you did this image file over here, when you make this image file, this is what it's going to do, right? It's going to show you cat or dog. So in the first run that it runs is a cat. So if it's a cat, it did nothing, right? But if it's a cat, it is do nothing, so it goes to the next one, which is else. Okay, so is cat, then it started to count 1 plus 1. So from 0, cat is going to be plus 1. So the first one will be cat plus 1, so it's going to count. Okay, and this is going to be repeated because I put 4. So this is a for loop. Okay, and then I'm just going to print the number of the dog counts, how many times it run until finish, because there's 2500 cats and dogs all over this file names, right? All over this file. So it's going to run, and then it's going to count for me the number of dogs and also number of cats. This is what it's going to do. Okay. If you don't understand this part, yeah, please comment below. Then I will explain you further. Okay. All right. So I'm going to run this. Okay. So number of dogs will be, wow, 1255. It's actually quite nice. It's actually balanced. So if it's not balanced, there is more steps for us to do to make the data set to be balanced. Okay, so now let's try to display the image of the resize data. I mean the resize image. Okay, it should be the same, but it should be just change the width and the length. Okay, so let's say display resize image of dog. Okay, so it's the same thing. Yep. Yeah, it's actually the same formula like that. Okay, but okay, this one there's a dog. Dog is 7311. I don't like this dog, like not clear. That's why I use another one. I don't know. I change. Maybe let's see. 110 668. Okay, let's see. Or 3075. Shorter. 3075. Okay, let's see what dog is that. Oh, so cute. Okay. Okay, cat also like so dark an image. So maybe I change also this dog image. maybe what dog number? What up? 1963 is kind of cute. Let's try 1963 for dog. Seems like I did not know each they are born. Is it? I don't know. We all not born yet, but it's oh so sad. It's being like jail like that. And the one. Okay, let's find another one. Which one? 5500. Let's see. I'm very choosy. Sorry about that. Let's see. 5500. Okay, like this one is the first one that I choose actually. So this cat, I do not know which one the first one I choose actually, but I think let me try just 7146. 7146. Let's see. Okay, yeah, this is the first one that I chose actually. Okay, so let's see the dog again. Which one? This one, right? The same 5500. So it's the same one, but just let's see it's resized or not. Okay, 5500. So yeah, it's resized. Can you see that? This one is like so much bigger, right? Okay, if I were to let's say image of cat. Okay, let me just code. So image of cat, this one CAT. So let's see what's the cat number just now. 7146. 7146 here. 7146. Okay, so let's try to run. Okay. Uh cannot find, is it? Not found. Dog. Oh, it's because it's dog. Should change to cat. Yeah, there's no such thing. So cat. Sorry about that, cat. Yep. Okay, so can you see the size just now is a pretty like this one and this one different size, right? But now it's similar. Everything will be similar. If even you change any number, so all everything which is from the 2000 because we just want to change 2000, right? Remember we mentioned 2000 here in the range of 2000. So it will change all the 2000 images. Okay. So great. Now it's all in the same. It's in the same size. So next we are going to create labels for the resized images of dogs and cats, meaning that I want maybe cat to be 0, dog to be 1, for example. Okay, so that later on when we train it, you know, it will it's easier for it I mean okay, model and computers, of course, they do not know images, they do not know numbers, they do not know strings. Remember, at that time we have to convert it into hot encoding, right? Like either female or male, we have to make it a 0 to 1, right? So the same thing for images also. Okay, so let me just give a text and say creating labels. Creating labels for all the resize for resize. Okay, I didn't resize everything, just 2000. So I just put for resize RESIZED images of cats and dogs. Okay, so what I'm going to do, in a sense that I'm going to make cats would be 0 and dogs would be 1. Okay, so let's do it. Let me code. So first I will want to create a loop again because I don't want to do one by one. There's 2000, 2500, right? But in this data set of resized images, there's only 2000. So I don't want to do one and one and one. So we're going to always use loop, okay? So creating, let me just put creating a loop to assign labels. Okay, so the loop function is very make things good, right? We as human, we don't like to repeat things, so let the computer do the repetition for us. Okay, so as dot list directory, which is inside this content of yep the images that has been resized, right? This where is it? Resize images here. Okay, let me close the train close. Okay, the resize images here. Okay, I'm going to create a label, and the label is first is nothing. Okay, no, it's empty. So for I in a range of 2000, so the name is the file name is from, of course, the CAT. Why did I put, sorry, yeah, CAT, just CAT, just 3. Don't make a mistake here. Okay, so cat is just 3 letters. Okay, dog also 3 letters. So from 0, C1, A2, T. T is 3, right? And if name is dog, then the label I want to change it to 1. Okay, so else you change it to 0. That means, okay, if it's not dog, right, then it will go to else. Then else definitely is a cat. It's only got cat and dog, right? So if it's a cat, then change it to 0. Okay, so yeah, so then this labels is going to be appended to either 1 or 0. Okay, so let's try to run this. There's content, there's something wrong. Resize the images. Oh, I forget to put this one, sorry, yeah. I just tap, trusting the auto writing for me, no? Sometimes I got to check. Okay, so yeah. Okay, so this worked very good. So now let's try to see whether it's really working. So I'm going to print the labels from, let's say, I'm not going to print all the 2000, there's so much, right? So 0 to 5. Okay, always make like this is the head, and remember, and then print the length, also the length of those things that are labels in the labels. Okay, so let me just show it to you what I mean by this. Okay, 0 1 1 0, because we want 5, right, from 0. So 1 2 3 4 5, this is 5. So 0 means what? 0 means cat, right? And 1 means what? 1 means dog. 0 again means what? Cat, dog, dog. So 0, right, is cat, cat, dog, cat, dog, dog. Okay, if you were to see the very first one, right, before you do all this, it's like, where is it? Cat, dog, right? Cat, dog, cat, dog, dog, right? Is really correct, yeah? Okay, so this is what you just labeling it. Yeah, you're labeling. That means the cat is 0, the dog is 1, and this one you're just taking the total of 2000, all the labels of all the 2000 datasets, because it's only because I convert only 2000 ma. Okay, right? From the very beginning there, just now. For the this one, okay, the range of 2000. So the resize image only 2000. So I want to change all this to the 2000 is all being changed to 0 to 1. It's being labeled to 0 to 1. No more cat, no more dogs. Okay, the string is now changed to either 0 or 1. 0 stands for cat, 1 stands for dog. Okay, now we can print the values, okay, of the images of dogs and cats out of the 2000 images, because just now we we make we count the counts of um, cats and dogs from 2500, right? This one, where is it? 2500, right? And the count of cats and dogs is, where is it? Where is it? Too much computer makes my eyes also blur. Okay, 1500, right? From the 2500. But this time we're going to take only 2000, which is the resize image. So, okay, so now, okay, let's try to find the unique values in an array, like the unique arrays. I mean, the unique values in this array, right? and also the labels of their corresponding counts. Okay, so what we're going to do is that basically, right, let me just give a comment first. So counting the images of, eh, this is a text, so I no need to put this, sorry about that. Okay, counting the images of dogs and cats out of the 2000 images. Okay, remember this is only 2000. Okay, so let's try to count it. Yeah, so we go to code. So what I'm going to do, I'm going to do values comma counts. Okay, I'm going to give a variable for value comma counts. Okay, it gives to me very nice. Okay, NP unit, right? What it means by NP unit? This one, NP unit labels, is going to basically these NP unique labels. What it does is that it's going to return a unique value found in the labels. Okay, like the unique value is like 0 and 1, 0 for what, cat, and 1 for the dog, right? Whereas this count is true, right? It's going additionally, it's going to count for me the numbers of each values in this 0 of the values, the total numbers of the unique values for zeros, and the total values, the entire total values of the unique numbers in 1, which is dog. Okay, so this is what it's going to do. And so if I were to run this, you see, so it shows me the unique value is 0, which is cat, 1 is dog, and the total of cat is 962, and the total of dog is 1038. Okay, alright, looking at this number, again, it's not bad. It doesn't have much bias. The first one is of course better, right? Because it's exactly similar to each other. But this one also not so bad. 9 and 962 and 1038. Okay, so there is not much bias for us to train the model. So yeah, we can go by with this number, this value, that we don't need to make any more changes or adding more things in here. Okay, so let's go on. Okay, the next step is that we are going to convert the images to NumPy arrays. Okay, so convert. Oops, maybe I do the text first. Sorry about that. Convert images to NumPy arrays. Okay, alright. Why I have to do this, right? Basically, as you know, right, if you convert the resized images to NumPy arrays, it's make it easier for preprocess, right? So let's do it and you'll understand better. And I'm going to use libraries like import globe as well as import CV2 to do that. Okay, and later I will explain to you what is globe and what is CV2. Okay, basically, let me just comment. Okay, globe is like it is for file searching. Okay, so it makes things easier. SEAR searching. And CV2 is basically it's for image processing. Okay, image processing. Okay, yep. Okay, so what we're going to do is that I'm going to create a variable called maybe image directory equals to, okay, so this size image is a, let me just copy the path. Okay, so control V, I just need open and close this. Okay, but for this one I need to, don't forget the forward slash behind. Yeah, yep. And then okay, so basically this is just to define the directory where the images are stored lah. So you know that the images are stored in this folder, right? So the next step is I'm going to also define the list of what are all those extension that is allowed. Okay, so maybe I put image extensions. Maybe no need s like equals to. Maybe what I need is I want also PNG and JPEG to be all allowed. Okay, because I think this data set only contains of JPEG, doesn't have PNG. But the thing is that I do not know, maybe in the middle there is PNG. Okay, so I don't really bother to process. It's 2000 data set. Okay, to browse down one by one so troublesome. So to be safe, yeah, I just put PNG and JPEG. Alright. This is something wrong with here. It's supposed to be here. Sorry about that. Okay, so um when I mention this, right, it means that I allow all the images that has JPG and PNG extension. Okay, and then what I'm going to do, I'm going to initialize an empty list to store the file path. Okay, so maybe I'm just going to give files equals to um, first is empty list. Oops, empty list. Okay, then after that I'm going to look through all the extension and then collect the matching image files. You see the goodness of using this glob. Okay, this import glob, not import globe. I'm sorry about that. Import glob. Sorry about that. Okay, is it will do the looping for me instead of me using the for I blah 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 blah. Okay, so let me maybe I just comment here, loop through each extension and collect matching 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 image file paths maybe. Okay, so instead of using the for loop, I use the glob, so this make my life easier. Okay, so with just one line, which I will do file dot extend glob dot glob, and which is the glob is inside the image directory here. Okay, I have renamed it to image directory plus, and I'm going to use asterisk, which is like all the files inside this. Okay, so wait, I don't want to use double because I want to be very consistent. Okay, so this plus the extension. Okay, so whatever file in this directory, okay, plus the extension, okay, in the in the image extension, okay, plus which is for in image extension. Great. Okay, okay, so this fills all the files ending with PNG or JPEG in the given directory, right? This directory, and then it will append them in this file here. Okay, now the file is empty, right? So it will replace the file. Okay, so that is what is the glob will do, which make it things easier rather than you use a loop, right? Okay, let me check this. Okay, I think this is perfect. File dot extend glob image directory should be alright, but I don't know why they underlining files. Sorry about that. Files, you have lots of files, not just one files. Yeah, it's a and this is of files, right? Of files. Okay. Okay, so now what I'm going to do is that I'm going to read all the collected images, right? I'm going to give it a name as doc underscore cat images. Okay, great, start for me. So this is going to convert it to NP array, and it's going to, at this point, right? At this point of time, the doc cat images is a numpy already, and it will contain all the loaded images. Okay, so Yep, when you print, you can't see anything until you type print. Okay, so I'm going to type print so that you will see what I mean. Okay, but let me just give another. This is too much really. So I just click print dot underscore cat images. Okay. Okay, so what happens? Okay. Hey, how come it doesn't print anything? By right, it should print, yeah. Let me run again this. For file in files. PNG. Okay. Sorry about that, yeah. This one is why I need to open and close, open and close. I can't just do that. Okay, sorry about that. So print. So it's going to fetch from me all the files that is PNG and JPEG. It's going to print for me. Yep. Okay, so there it goes. Okay, all these images has been converted into arrays. Okay, every of it is being printed. What I'm going to do next is I'm going to make a variable called x, and I'm going to call this x as a doc cat images. Okay, this is going to be the cat images, doc cat images, whereas y is going to be the np arrays. Okay, so dot cats images is x, and the y is the one that is converted to arrays. Okay, so run this. Once I have done this and I have verified the x and y, okay, for the model to understand what is x and what is y, I am going to, let me do the text. Okay, I'm going to trim test split. Alright, so basically what I'm going to do, I'm just going to put x underscore train comma x underscore test. Great, it starts on me. So you're just going to train. X is going to be train and x is going to be test. Y also train, y also test. This is the variable that is going to perform this train test split x and y, and with the test size of okay, not test size because 20 here, but actually the training will be 80%. Yeah, correct. Sorry, the test size is 0.2, meaning that the test will be 20% of the entire data of the 2000 data, and the training will be 80%. Okay, and the random is state is equal to 42. Okay, I already explained what is random 42 in the previous video, right? If you don't know still, you can refer to the last video, or you can comment. Maybe I can reply to you. Okay, so let me just run this. I don't know why there's a red color. X underscore train. Oh, is it X is capital letter? This is a capital letter. X underscore test. Oh, it's underscore. My God. Okay, underscore test. So you're going to do this. Run it. Now you're going to print the shape. Okay. Let's try to print the X shape and the Y shape. To see how many are being trained and how many are being tested, even though you already knows that okay, you want 80% of the data, okay, of the 2000 data, 2000 data to be trained and 20% of the data to be tested. Okay, 20% of from the 2000 data to be tested. But to verify it again, just let's see. Okay, print x dot shape and x underscore train dot shape. Okay, and that was this X test shape. So we're going to see the total is 2000 X shape and 224 of the dog and 224 of the cat with, you know, 3 is character, right? Let's see, 80, right? Okay, so for the cat, I mean, sorry, not for the cat, for the training, it will be 1600 out of 2000. And training also 224, which is the entire thing, which is good. Okay, and for the test, 400 will be tested. Okay, out of 2000. So this is good. It's like 80 to 20%. Okay, this is what we want. Okay, so the next step is I'm going to scale it. Okay, so why do we need to scale? Basically, let me just give a text here. Okay, scaling. Okay, oops, typing. Okay, why you need to scale? Basically, the raw pixel, right? Raw pixel value usually spell it correctly. Okay, raw pixel value usually range from 0 to 255. Okay, but in this case, the image, I do not know what is the pixel. It can be very big difference from 0 to 255, and each image might have a different value of pixel. So that's the reason why I want to scale it, to make everything to be uniform, so there will not be a wide range of pixels between, you know, one image to another that is going to be dominant, okay, or denominate the others. So that's the reason why I will do the scaling. Okay, so now to do the scaling is just I'm going to do x underscore train underscore scale. This is just a variable I'm going to call it, is equals to, yep, okay, because the optimum number of pixel is 255, right? So I'm just going to divide it by 255. The same thing for x test scale, just x test divided by 255. That's it, right? So if I were to print this, let me run first. Okay, then I just can print this x print x train scale. Okay, so and also print x train test. Okay, print x test scaled. Okay, so if I have to print this, let's see. Oh, you don't know the difference, huh? This is actually x train. Oh, you don't know the difference. Okay, maybe I will just remove this first. Just print the x train scale. Okay, so looking at the value, this is 0 0.3, 0 0.3, 0 0.3, 0 0.89, 0 0.35, 0 0.35. I think it still has a lot of big difference, but at least it's all from 0 point something, right? Instead of from 0 all the way to 255. This is more scale, right? Comparing to from 0 all the way to 255, which is big. This all 0 point something. Okay, so this is good. Alright, so next I'm going to print the x test scale. Okay, let me see. So now you're going to print, you already print the train, let's print the test. Okay, so print x test scaled. Okay, so even here, instead of from 0 to 255, which is big, it's all from 0 point something, okay, which is good. This has been scaled. Alright, great. So the next step is, okay, so I'm going to comment it with text, build, no text, build neural network. So to create a neural network, there is two libraries that you need to import, which is the TensorFlow. Okay, so import TensorFlow STF. Basically, this TensorFlow is for deep learning and neural networks. So I import it, and then import also import TensorFlow hub underscore hub as hub. Okay, so I'm going to import these two libraries. So import TensorFlow hub for pre-train the model and transfer learning. Okay, um, in TensorFlow, right, is actually a deep learning framework used for building and training the neural networks. Then TensorFlow Hub is a library for using pre-trained models like image classification, NLP, So this will actually reduce the training time and improve performance. So that's why I'm importing this. Okay, so once I've import this, I'm even going to use the MobileNet model. Remember I told you in the very beginning of this video. Okay, the next step is that remember we have done the data set, we have to do the image processing, we have to do the train test split. So the next step is about pre-training the model with MobileNet model. Okay, that of course I've mentioned to you there is a different type of model that we can use such as VGG, ResNet, Inception, MobileNet, YOLO, etc. But for this video we are going to use MobileNet model. Okay. This case, I'm going to use the MobileNet model, which I already explained to you a little bit in the very beginning of this video, right? So I'm going to give a variable called MobileNet model equals to, okay, this is the link that you can copy in the description video, which I've taken from Kaggle. You can also try to Google it lah, but to make your life easier, I actually have place for you in the description below. Okay, so you guys just go to this website, just copy from here. Okay, so yeah, Control C, just go back here. Okay, Control V. Okay, and then yeah, this is actually using this URL of the pre-trained MobileNet version 2, which is for the TensorFlow hub. Okay, this is what it does. Okay, let me remove this. Okay, so remember I have actually explained to you what is transfer learning. Okay, so it's basically a model that has already been trained. Okay, so when we get that link just now from the Kaggle, that model has already been trained. Okay, so um, we are using that model to also train our model, so we don't have to start from scratch, which is long process. Okay, so we reuse that, but just we edit a little bit. Okay, so I'm going to tell you which part that we need to edit. Okay, so as I've mentioned, this one is the link of the Kaggle that they have done. They have trained, okay, the model. So I'm just going to reuse it so that I can train my model. But also I don't want to use it like for everything. Okay, so let me just comment it. Okay, maybe how do I comment it? Maybe I comment it here so that you will understand. Oops. Okay, so maybe it is, I'll comment it like this is the URL of the pre-trained mobile net version B2 model from the TensorFlow hub. TensorFlow hub. Okay, so we have taken this from the Kaggle, which is nice. You just have to reuse it and just edit a little bit. Okay, now we are going to load the pre-trained our pre-trained mobile net version 2. Okay, this is just a model. Okay, model as a keras layer. or you want to, some people pronounce it as keras, okay, so it's up to you, keras or keras, okay. So so I'm going to call my model as a pre-trained model, okay, and yep, it types for me. That's great. Okay, so what it means by this, so this one basically, right, it is actually the URL of the pre-trained model, which is this one, okay, that I make use of. That's why I said MobileNet model is go to this link, right? So when I use my pre-trained model, I said, okay, I use the keras layer, but you go to this link to reuse this model that has been trained. And I input shape, which is 224 by 224. Remember, we have resized the images to the height and the length, right, to be 224 224. Okay, and also 3 for the, remember we have done this before, right, the cat and the dog, 3 characters. Then trainable force, what it means by trainable force, this is going to freeze the model's weight to use it as a fixed feature extractor. Okay, never mind, I'll explain you further later on. Okay, so let's run this first. This one, when you run, right, you will not do anything yet, okay, because you do need the next step definitely. Okay, this one is just to inform that I am going to use the same model, similar model that is being used in this website, okay, in this URL, okay, but I have my own shape, etc. Okay, so what I want to do is also I want it to be, okay, sorry, I forgot to explain to you what is hub keras layer. Okay, so this is basically a predefined model such as what we are using here, the MobileNet model, okay, or the bird or aviation net is what I've mentioned just now previously in the beginning of this tutorial, this video. Okay, so all this is from, all this keras layer is all from the TensorFlow hub. Okay, it's all from the TensorFlow hub. So this one, right, it can be used as feature extractor. Why? By setting these to false, actually I can actually use for fine tuning. Okay, I can use for fine tuning. It actually simplifies transfer learning, so by allowing the developers to use the pre-trained feature vectors instead of training from scratch. Okay, so that's the reason. Okay, so now I'm going to put number of classes equals to 2. What is this? Basically, this is to define that my classes is, one is dog, one is cat. So I only have 2 classes, 2 binary, which is 0 and 1. Okay, and then I'm going to load the pre-trained model without the top layer. So this one I already said freeze, right, trainable is equal to 4, so freeze this pre-trained model. But when I want to load it now, I want it to load, yeah, so but this one, when I load the pre-trained model, okay, load the model, okay, load a pre-trained model, but this time when I want to load is without the top layers. Okay, without top layers, because I will make this, I will add these top layers to be with the number of classes, which is 2. Okay, so that's what I want to edit a little bit from the the, the real model, which is from this website. Okay, so what I'm going to do, okay, pre-train model is equals to tf dot keras. I'm going to just use applications dot application. Okay, great, that's for me. Okay, so application MobileNet version 2, which already defined the input shape 224 224 by 3. Okay, so this time include top is equal to false. Okay, I don't ask them to froze anymore. You can still run, but I want you to remove the top layer. Okay, and the weight image net, what it means by image net. Okay, this one is normal lah. Okay, you just like the image net is basically just to, what do you call it, to how do I define it, for image net is like you make it to load the pre-trained weights from the image net data set. Okay, so whatever they have learned, right? The model, they take the knowledge, okay, from the large scale image classification. You can include that. Okay, the only thing I don't want is to remove the top layer. Okay, and then here I put the classes is equal to this number of classes. That means I remove the top layer, but I add the layer, another layer, which is 2. Okay, so this is what I meant. Okay, so the next step is I want to ensure that the model, okay, the model outputs is how do I say that now? Ensure that the model outputs a flat vector, okay, a flat vector, a flat feature vector lah. Okay, so what I mean by a flat feature vector, that means the image, right, is 3D, right? So I'm going to flatten it. Okay, I'm going to flatten it in the sense that I'm going to make it into just 1D. Okay, okay, this is good for training the model. Okay, so what I'm going to do is that first I need to get the output of the feature extractor. Okay, so let me just name this as maybe x. Okay, x is equal to pre-train underscore model output. Okay, so I'm just going to label as x, which is the equal to pre-train model output. This is to get the output of the feature extractor. Okay, maybe I comment it also, get the output of the feature extractor. Okay, and then what else? Then I'm going to apply the global average pooling to flatten the feature maps. Okay, so it is to convert the 2D feature maps into 1D vector. Okay, so what I will do, I put x is equals to, great, they did it for me, tf keras global average pooling 2D. So what is going to happen from 2D is going to convert for me to 1D. Okay, so they just write for me. They write for me is global average pool. I do not know what it means. Okay, and I don't want to write this. Okay, I will just write so that you understand what is it about. Okay, so basically these things, this syntax here, this code here will actually converts the 2D feature 2D feature 2D feature map into 1D vector. Okay, so that is what this do. Okay, and then finally you have to add, okay, you add the fully connected dense layer for this classification. So what you have to do is that you put output underscore tensor equals to tf dot keras layer. Okay, keras, okay, type it for me quick. Keras layers dot dense number of class, which is 2, activation softmax. Okay, and x. Okay, so basically this line here is basically what it does, right? It just apply, it just how do I say that? It just apply a fully connected dense layer for classification. So what it means, right? So this final layer, right, will be, okay, how do I comment it? So yeah, it basically final layer with softmax will be activated, or softmax activation. Okay, so the final layer with softmax with will be activated. Okay, with activation. Okay, so that is what it means. Okay, and then oops. Alright, so now Now you need to create the new model once you have actually, let me just run this. Okay, great. So once you have done this, right, you can actually create the new model with the modified output layer. So we have actually modified this layer, right? So we just let me just comment it. So create the new model with the modified output layer. So we're going to call it as model equals to, yay, they always start for me. Thank you so much, Google Colab. They have correct models, but not super correct. Okay, so I need to remove this one. While models repetition model input equals to pre-trained model, which is this one, the pre-trained model, right? Yeah, dot input, and output is equal to the output tensor. Okay, great. So finally, once we have done, we define this model, we're gonna print the summary. Okay, so you print the summary. So let's see. Okay, this may takes a little bit of time. Okay, so we'll see. Oops, where did I go wrong? Print. Oh, sorry, it's not print. It's just print summary. It's just this way got print over here, some model. Okay, dot summary. But maybe I can just put text here. Print comment here. Print the model summary. Okay. So I'm so excited until I type wrongly. So okay, let's try to run. Yeah, so that's it. It shows you the result, everything. Okay, okay, so looking at the result, let's try to understand what this model has done. Okay, so basically, why do we do this? It actually helps the model to focus on important patterns, and like for example the output shape, right? It starts with, let's say, 2 to 4, 2 to 4 by 3. The size, remember, 2 to 4, 2 to 4 by 3. 3 is the color, RGB, red, green, and blue, right? So as it goes further on, it reduces and shrink and shrink and shrink, right? So um, when you reduces the image size, right, it makes it easier to process. So all these things that we have done, right, to build the neural network is resulting on these results, which actually allows the model to recognize objects better, and even if they are in different position. Okay, so like for example, okay, you let's take a look at this. The input is like, for example, 2 to 4, 2 to 4, 3. Okay, the size, right? Because we have resized the image to height 2 to 4, weight 2 to 4, and the color is 3, red, GB, red, green, blue, right? Then as it goes on, it shrinks, make it smaller and smaller size, so make it easier for them to process, right? And then the convolution feature detection over here, for example. Okay, um, remember from 2D we also convert it to become a one vector, right? 1D vector. So it's easy for them to understand also the image. Okay, when it filters over the image and creates a small version of it, so it helps them to keep only the important details. Okay, so what else? Okay, so yep. What are the things that we can talk about? So the parameters is basically the weight of the model that it learns during the training. So if you know the formula, right, it's like filter size times input channel and also plus the bias, right? Here we don't even have to do the calculation. They train themselves and they calculate it by themselves, these parameters. Okay, so imagine for us human, if we need to do all this stuff by ourselves, it takes a long time. But just with a few coding, okay, of all this coding and using the library and also making use of the pre-trained model, okay, it is able to train itself. Okay, make it more simpler. So let me just give you a simple analogy. Okay, So imagine you have a big cake, okay? And this big cake has a lot of chocolate chip, right? So you want to find the pattern. Where is the chocolate chip? So the convolution 2D layer is like this magnifying glass. It will move around this cake, okay? Every little part of it slowly, slowly, and every inch, every pixel will goes around a little bit, okay? To find the patterns, checking small areas to find patterns. Where is this chocolate chip? Okay, so after scanning, you now have a map of where are all these chocolate chips, but at a smaller size. Okay, so you got it? I hope you understand this analogy, yeah? So just compile this. So there's a code here, okay. So just model, compile, because this is a bit too much, right? So let's compile this. And there's also something called optimizer called Adam. Everything is done for you. So I'm just going to make use of it. Okay. So this optimizer called Adam. Yeah, it's start for me. And it's even okay, I'm not going to use this sparse categorical all this. Okay, I'm going to do uh the keras, okay, the TensorFlow keras. So tf dot keras losses losses not sparse categories. Yeah, then I'm going to use this category classes. Okay, categories, categorical uh, cross entropy. Okay, and yeah, from logic equals to true, then matrix is good. Okay, so when you run this, it will not do anything, but basically what this do is that, okay, there's another line that you need to type in, which is model.fit x underscore train, and of course you scale it, the one that you have scaled it, right? Scaled, okay, and also the y train, y underscore train, okay, and this time is epoch, okay, and I'm just going to give a value of 5. Okay, later I'm going to show you what happens. Okay, this one might takes a bit of time, might like 4 minutes, etc. So I'm going to pause the video until it really runs. Alright. Okay, this takes some time to run. Honestly, it's like more than 5 minutes. Okay, so basically, this feed X train, right, is to train the X train skill and Y train epoch 5. It means like this is a method that trains the model using the provided data. So it will iteratively like adjust the model's parameters weight to minimize the loss function. Okay, so you can see the loss function is reduced. Okay, so the accuracy is about 90%, which is not bad, yeah. The loss function like this is a bit high, 0.6. Okay, 0. Okay, it's good, 0.068. I thought 0.6, okay, 0.60. Okay, so it's good to use this method to adjust or to minimize the loss function, okay? So that's it. And the last part is, of course, um, to print the score and the score for the test loss and the test accuracy, because it's a train, right? So we already done the train, so let's do also for the for the score for test loss and the accuracy. Okay, so let me just give it a score. Accuracy is equals to model dot evaluate x test okay, this time is scale as text scale and y test is so. Right, so I just tap it. Okay, great. Okay, so basically, this thing doesn't go up. Okay, so basically, this is to evaluate the score of and accuracy for the loss and the accuracy. Okay, how much is it? So let's try to print and see. Oops, there is an error. I didn't close the bracket. Okay, so just play it. Okay, so from here you can see later on how much is the accuracy, etc. Okay, so let it run again. I think this also will take a few minutes. So let me just do the predictive system. Oh, okay, good. It's not a few minutes. It's just like one minute. Okay, so the test loss is 2.39. Not so great, but okay lah. This test accuracy is about 80%. Okay, so it's still accepted. Okay, so let's do the predictive system now. Let me just go to do the text, which is predictive system. Okay, so here we just put the input underscore image path. Okay, so let's just put let's say input. So you just put you can just say path of the image too to be predicted. This is something that you ask the user to place in the path of the or link of the image, right? And then after that you just go to input. Okay, just input underscore image. Okay, and this is CV2 for reading. Okay, so you're going to read the input image path. So input image path. Okay, so it's basically just reading the whatever path that they have given, and then you're going to show also, okay, the image of whatever the person has input. So bcv2 underscore I am show input image. Okay, so whatever um, image a person have sent, okay, by the link. Okay, they have to upload first definitely by the link of over here. Okay, the path, and then it will just show the image. Okay, and then of course you need to definitely resize. Remember, these are all something that we have done before, right? But this is for the predictive system. So you input image resize, okay, which is equals to cv2 dot resize. Okay, great. Let you inform me. Yeah, we have make everything to be 2 to 4. Remember, right? It's all above that, right? Remember this 2 to 4. Okay, I have resized it to 2 to 4, right? Before this, yeah, 2 to 4. All right, and then also divide it by 255, which is the pixel. Okay, so pixels from 0 to 255. So this is all that we have to again do the same thing. Okay, so this is based on the image at the input. We do the same normalization as what we have done and train the model. Okay, if not, the model will not be able to perform it with good accuracy. Okay, so we have to make the model same as what we have trained it just now. So again, image rate scale 1 2 2 4 4 3, remember, and then now you input prediction, the image you reshape it also, then you print the input prediction. Okay, so once you input the image the prediction, right, whether it's a cat or the dog, maybe I also want to make a label. Okay, because it should have a label, right? So input the prediction label, which is I'm going to use okay, good, argument max input prediction. Then I'm going to print the input label. So in this case, oh, they do it for me also. Okay, so if input label is 0, remember this is a 0 is a cat, right? You print this image is cat. Else, if it's not 0, that means it's a 1. Then you says the image is a dog. Okay, so yep, that's about all. So let's try to run this. Okay, so you can see, let's say I have to go and find the image first lah. Okay, let's say I go and find image of a cat, for example, cat image. Alright, so maybe I like this cat. Okay, simple one. Okay, just right click, save image as. Okay, I'm just going to save in the desktop as cat.jpg. Okay, because remember we're not using GIF. Just now we train it to be PNG and JPG, right? So cat.jpg, save. Oh, do you want to replace? Okay, yes, I already have it actually, but now I'm still going to find a dog image. Okay, dog image. So, what a cute dog, huh? So maybe this one. No, this one more clear. Okay, so just save image as dog dog.jpg. Okay, so if you want to do PNG also can, but I just put JPG because it's the maximum. Just now, let me see. Oops, sorry about that. Okay, so now I'm going to upload. Let's say I upload both of the cat and the dog. Yeah, it's a cat and so it's a dog. So oops, sorry, cat and dog. I'm just going to upload both of them. I'm going to open. Okay. Just wait for a while because it's still uploading here. Okay, let's click OK. So where's my cat and my dog? Yeah, so you can see my cat path, right? Is I copy the path, so I just paste the path here, Control V. It is a cat, so enter. Oops, there's an error. I am red is not defined. Where is I'm red? Oh, yeah. Input image. CV2. Ah, okay. I'm red input image path. Okay. So basically, I didn't put the CV2, which is here CV2 should be dot instead of comma, right? Yeah, so let's run it again. So again, I paste the path, Control V, okay, which is this. Even if I don't name it as cat, yeah, you can name it as anything, guess me or whatever, right? So yeah, it shows the image, which is actually the input prediction right here. You're going to input it, what it did, right? You ask for the input of the path, so you put the path. Okay, then it's going to read the image. So this is what it's going to show when you say you read the image already, then you show. Okay, so you show the image, and after that you're going to do all this based on what you have done before. You've got to train it same as what you've done before, right? And then you print the prediction. So the predictions, okay, this is like if it's a 0, okay, is a cat. If not, is a dog. So this is a cat. Okay, so let's say I do it again. All right, let me run it again. So this time I'm going to get the dog. Okay, so just copy the path. So let me just Control V. So enter. Okay, so this is a dog. The image is dog. Yeah, so yeah, the prediction box. So that is how machine learning for prediction of transfer learning as well as deep learning is all about. I hope you have learned something in this video, and if you do, please like it and share it. Yeah, thank you so much guys, and have a great evening. Take care.